Alright you guys, let's take a look at 8.2, linear equations and two variables. So what it means with two variables is just that we're going to see a y and an x. We're going to see two different variables, two different letters in the equation. Now a solution is when we plug in a given point into the equation and it's equal on both sides. So we plug in an x value, we plug in a y value, and those numbers make the equation work, make it true, make it equal. The graph of an equation just means that we're going to graph points on a coordinate plane. Now linear, if you underline the first four letters L-I-N-E, it means it will form a straight line. Now when they say function form, that just means we have to solve for y. Y has to be by itself on one side of the equal sign. So for example, y equals 2x minus 4, that's in function form. If it looked like this, 3x plus 2y equals 6, this is not function form. Okay, so take a look at example 1. We need to tell whether the point 5, negative 1 is a solution of the equation x minus 3y equals 8. Well, I would tell you to grab your red pen and put an x above the first number they give you, and then draw an arrow to the x, that's where the 5 is going to go, and then with your blue pen, draw a y above the second number they give you, the negative 1, and draw an arrow to the y. That's where the negative 1 is going to go. So I love how your book says this. Always write the original equation. So x minus 3y equals 8. And now plug in the values. So the 5 goes in for the x minus 3 times, and notice how they put it in parentheses, put in negative 1 for y, and then put an equal sign, 8. Now the equal sign, there's a question mark there because we're not sure that it's going to be equal. And then where you see the minus sign, add a line, change the sign. So we have 5 plus, and then negative 3 times negative 1 would make a positive 3. So they're saying, is it true that 5 plus 3 equals 8? And of course, then add the 5 plus 3, so 8 equals 8, and so we'd say yes. 5, negative 1 is a solution. Okay, so let's take a look at the checkpoint. They want us to tell whether the ordered pair is a solution of the equation 2x minus y equals 5. So remember, write the equation 2x minus y equals 5. And then above the first number, put the x, so the 0 is going to go in for the x. And then the negative 5 is the y, so the negative 5 is going to go in for the y. But you got to be careful with that, okay? So now write 2 times 0 minus, and now put in your negative 5, equals 5. And so 2 times 0 is just 0. Now the minus the negative, remember that becomes a big giant plus sign. So 0 plus 5, does that equal 5? Well, yes, 0 plus 5 is 5, so 5 equals 5. Now I want you to notice something. I have the equal sign pretty much lined up here. I want you to keep the equal sign going, okay? And so yes, it is a solution. Take a look at number 2. Again, write the original equation, 2x minus y equals 5. And now put an x above the 3, because we're going to replace the x with a 3, and put a y above the 2. We're going to replace the y with a 2. So now plug in the values. So 2 times 3 minus 2. Does that equal 5? Well, 2 times 3 is 6, and then bring down the minus 2. And 6 minus 2 equals 4. So 4 does not equal 5. So put the equal sign with a line through it. So this means no, 3, 2 is not a solution to that equation. Okay, take a look at number 3. Again, write the original equation they gave us. 2x minus y equals 5. And then we're going to put a negative 2 in for x, and we're going to put negative 9 in for y. So I have 2 times negative 2 minus a negative 9. Does that equal 5? Well, 2 times negative 2 gives me negative 4, and then the minus a negative 9, that becomes a big giant plus 9. Well, negative 4 plus 9 makes 5, and 5 does equal 5, so yes, that is a solution to the equation. Okay, take a look at example 2. Now when they want us to graph this, they want us to graph y equals negative x plus 1. Now, I'm not crazy about this kind of a table that is horizontal. I think especially when you're starting, you should do a vertical table. So I want you to do the x column, put a workspace, and then the y column. Now, the values that we usually use for x are easy to input. So we always start with 0. That's easy. Positive 1, positive 2 is easy. And then you should have a negative value. Let's do negative 1. And now see how y equals negative x plus 1? You want to put that expression right here. So negative, and then in parentheses, leave a space for the x, plus 1. Negative, parentheses, plus 1. Notice how I copy that all the way down. And then put the values in. So the opposite of 0 is still 0, plus 1 is 1. So that's my first point that I would graph, 0, comma 1. So I'd start at the origin. 0 means don't go left or right, and the 1 for the y tells me to go up 1, and I put a dot. And then I'm going to plug in a 1. So the opposite of 1 is negative 1, plus 1 would be 0. So I'm going to graph the point 1, comma 0. So I start at the origin. The 1 tells me to go to the right 1, and 0 tells me do not go up or down. Just put that point right there. And now I'm going to plug in a 2. So the opposite of 2 is negative 2, plus 1 would make negative 1. And so I'm going to graph 2, comma, negative 1. So I start at the origin, I go to the right 2, and then down 1, and I put a point. And now if I plug in a negative 1, well, the opposite of negative 1 is positive 1. 1 plus 1 makes 2. So I have to graph negative 1, comma 2. So I'm going to start at the origin. I'm going to go to the left 1 and then up 2, and I put a dot. Now you should notice if you did all of your arithmetic correctly, these are going to perfectly line up. And so you're going to use your straight edge and draw a straight line and then put arrows on both ends, because the answer to this is not these 4 little dots. The answer is the entire line, and the line is infinitely long. Okay, so let's look at example 3, some special cases, okay? So what if they wanted to graph an equation that just looked like this, y equals negative 2? So if I just want to graph, look over in the margin, y equals negative 2, I would do my x and my y table. But notice how I didn't leave a work column, because there is no work to show. If I plug in a value for x, it doesn't matter. The answer is always negative 2. So what I want you to do, under the x, let's put our inputs that are really easy. 0, 1, 2, negative 1. But no matter what I pick for 0, they're telling you that y has to be negative 2. It's frozen. So underneath the y column, just put negative 2, negative 2, negative 2, negative 2. That's what they're saying. No matter what x is, y has to be negative 2. So now you graph the point, 0, comma, negative 2. So start at the origin. 0 means don't go right or left. Negative 2 means go down and put a point. Okay, 1, comma, negative 2. Start at the origin. The 1 means go to the right 1. Negative 2 means go down to negative 2 and put a dot. 2, comma, negative 2. Start at the origin, go to the right 2, and then drop down to negative 2 and put a dot. Negative 1, comma, negative 2. Start at the origin, go to the left 1, and then go down 2 and put a dot. Now you'll notice these line up perfectly, so grab your straight edge, and I want you to draw a perfectly straight line through those 4 dots and then put arrows on both ends. Because remember, the answer is not the 4 dots, the answer is that whole entire line, which has an infinite number of solutions, an infinite number of dots. Okay, look at B. What if they wanted us to graph x equals 3? So in the margin, put x equals 3. And it's the same kind of deal that they're saying x is frozen at 3. It can't be anything else. So in your x column, you just put 3, 3, 3, 3. Now in the y column, you're going to have to make up easy numbers to graph. And usually we start with 0, 1, 2, negative 1. And now you graph these ordered pairs. So 3, comma 0. So start at the origin. The 3 tells me to go to the right 3, and 0 says don't go up or down. Put the dot. Okay, 3, comma 1. Start at the origin, go to the right 3, and then go up 1 and put a dot. 3, comma 2. Start at the origin, go to the right 3, and up 2 and put a dot. And then 3, comma, negative 1. Start at the origin, go to the right 3, and down 1. And now you have your 4 dots. Take your straight edge and draw a perfectly straight line through those 4 dots and put arrows on both ends. So this would produce a vertical line. The y equals negative 2 produced a horizontal line. Okay, so take a look at example 4 with me. They want us to write 3x minus y equals 2 in function form, and then graph it. Well, remember, function form means I have to solve for y. So I showed my work over here, okay? If I have 3x minus y equals 2, and I want to solve for y, I would circle the y, bring down the wall. That means I want to get rid of the 3x. The only way to get rid of the 3x is to subtract 3x on both sides of the wall. So that gave me negative, and put in that invisible 1, negative 1y equals negative 3x plus 2. And now I circle my y, bring down the wall, and I have to get rid of that negative 1. Now the way to get rid of it is to divide by negative 1. But watch this. I have to divide each term by negative 1. And so that would give me y equals, and then negative 3x divided by negative 1 is positive 3x. And then 2 divided by negative 1 is negative 2. So the equation is y equals 3x minus 2. Now that I solve for y, I can do my x column, work column, y. Okay? And so I'm going to come up with some easy values for x. 0, positive 1, positive 2, negative 1. For my work, I copy the expression 3 times x minus 2. And I keep doing that. 3 times x minus 2. All the way down. And now I plug the numbers in one at a time. I plug 0 in. 3 times 0 is 0, plus negative 2 is negative 2. Then I plug in a 1. 3 times 1 is 3, plus negative 2 is 1. Then I plug in 2. 3 times 2 is 6, plus negative 2 is 4. And then I plug in a negative 1. 3 times negative 1 is negative 3, plus negative 2 is negative 5. Now I have to graph these points. So start off with 0, comma, negative 2. Start at the origin. The 0 means don't go right or left. The negative 2 means drop down to negative 2 and put your dot. Then let's graph 1, comma, 1. Start at the origin. I go to the right 1 and up 1 and I put a dot. Then I graph 2, comma, 4. Start at the origin, go to the right 2 and up 4 and put a dot. And then I graph negative 1, comma, negative 5. So I start at the origin. Negative 1 means go to the left 1. Negative 5 means drop down to negative 5. And now I was using a toolbar and I see it didn't go perfectly. But you're supposed to use your straight edge and draw a perfectly straight line through all of those points. And then put arrows on both ends. So the answer to this, the equation that we graph, is right here. It's that linear equation. Okay, take a look at checkpoint number 4. They want us to graph two different graphs. They want us to graph y equals 4 and x equals negative 3 on the same graph and then tell whether each is a function or not. Okay, so let's start off with the y equals 4. I put that right here. Y equals 4. Remember, y is frozen at 4. So do your x and your y table and make up values for x, 0, 1, 2, and y is frozen at 4. So just copy 4, 4, 4 all the way down the y column. And now you want to graph 0, comma, 4. So I'd start at the origin. 0 means don't go right or left. The 4 means go up and put a dot at 4. Okay, and then 1, comma, 4. Start at the origin, go to the right 1 and up 4 and put a dot. And then 2, comma, 4. Start at the origin, go to the right 2, go up 4, put a dot. And then for the y, I used a blue line and draw a straight line through those points and put arrows on both ends. And notice how this is a horizontal line. Now, it is a function because of a couple of things. It would pass the vertical line test. Okay, it never had any points stacked on top of each other. Another way to look at it, all the inputs were different, okay, and that's all you have to do. So yes, y equals 4 is a function. Now let's graph the other one, x equals negative 3. So I put that right here, x equals negative 3. So I did my x and my y chart. Now this is saying x is frozen at negative 3. So I just put negative 3, negative 3, negative 3 all the way down. Now for the y, make up numbers that are easy to graph, 0, 1, and 2. And so let's graph this. Negative 3, comma, 0. Start at the origin. Negative 3 told me to go to the left 3, and then 0 said don't go up or down and put a point. Negative 3, comma, 1. Start at the origin, go to the left to negative 3, and then up 1 and put a point. -3, 2. Start at the origin, go to the left -3 and up 2 and put a point. And now I used my red toolbar to make a straight line through those points. And notice that this line is a vertical line. And so now notice if they want me to tell them if it's a function or not, see how these points are stacked right above each other? We're not allowed to have that. So no, this is not a function.